Welcome to Maths and Science by IITian. In this, we will be discussing in this lecture about the perfect numbers. Are squares are perfect numbers? We will be discussing about the perfect numbers. We have discussed in my previous videos on different types of numbers on number theory, including Mersenne number and also Fermat number, Fermat prime number. In this class, we will be discussing about the perfect numbers. Let's delve into the lecture. As per number theory, what is a perfect number? What is a perfect number? A perfect number is a number for which the sum of the divisors is equal to number itself except the divisor of number itself. That means, example, 6 is equal to 1 plus 2 plus 3. 1 is a divisor of 6, 2 also and 3 also. Sum of all these. Even 6 is also there, but we should not take the same number as a divisor. Then 1 plus 2 plus 3 is equal to 6. That means 6 is a perfect number. Now let us take another example also for clarity. Can we take 28? 28 is equal to what is the total of 28? Divisors 1 plus 2 plus 4. 4 also divides 28. Then 7 4s are 28. 1 plus 2 plus 4 plus 7 plus 14 is also divisor. But 28 also divides 28, but we should not take that number. This total becomes 1 plus 2 is 3, 3 plus 4 7, 7 plus 7 14, 14 plus 14 is equal to 28. That means it's a perfect number. Then, what is a square? Multiplication of the number itself by itself is a square. For example, a is a number. A into a, that is equal to a square, is a square. Six is a perfect number here, what we have found. What is 6 square? 6 into 6. Is 36 a perfect number? No. 6 is a perfect number. 28 is a perfect number. 496 is a perfect number. Like this, we can find out 8128 is a perfect number and so on. There are limited perfect numbers. And as the number system goes up to infinity, we can say there are many, infinite number of perfect numbers. Because we cannot compare whatever we can calculate with infinity. When you compare with number system, the perfect numbers are lesser than the total numbers available, integers available. In the total integers there are squares. Can every square be a perfect number? Can square be a perfect number? Any square? That's what we are looking at it here. Can squares be perfect numbers? But at the face value, for 3, 4, 10, 20 numbers, we can say that square is not a perfect number. But there are infinite numbers. Then we should have a procedure to find out whether square is a perfect number or not. Now, we know that sum of the divisors of that particular number except number itself is called the perfect number. If that is equal to the number itself, sum of the divisors other than the number itself is equal to the number itself, then it is called a perfect number. We have seen the example 6, 28, 496 you can do, 8128 also you try and do it. As per Euclid, please remember this. An even number is a perfect number. An even number is a perfect number if it obeys or if it is like 2 to the power of p minus 1 into 2 to the power of p minus 1. It is in this form. Where p and 2 to the power of p minus 1 are primes. Where p and 2 to the power of p minus 1 are primes. To understand this, let us take the example of 28. 28 is equal to 4 into 7. What is 4? 2 square into 2 cube minus 1. 7 is 2 cube minus 1. 2 to the power of 2 is equal to 2 to the power of 3 minus 1 into 2 to the power of 3 minus 1. It is in the form 2 to the power of p minus 1 into 2 to the power of p minus 1. You see that this is different and this is different. It is 2 to the power of power is p minus 1. Here it is 2 to the power of p minus 1. What is the value of p from here for 28? P is equal to 3. And what is the 2 to the power of p minus 1? 2 to the power of p minus 1 is equal to 2 cube minus 1, that is equal to 7. This p and 2 to the power of p minus 1, 3 and 7 are prime to each other. That is also one of the conditions. That means it is called as an even, 28 is called as an even perfect number. What is 2 to the power of p minus 1? I have already explained you in my previous classes. Please visit those videos. 2 to the power of p minus 1 is equal to Mersenne prime. Please remember this also. This word is also very, very important, regularly being used in the number theory. If somebody says that something is a Mersenne number, then you should think about 2 to the power of p minus 1. It is Mersenne prime. It is a Mersenne prime. I have defined this in my previous lectures. Mersenne prime. That means we can define a perfect number also this way. Perfect number is equal to in the form. Let us try to define what is there. Perfect number. We need not be always book definitions only. We can develop our own definitions. Two to the power of p minus 1 into Mersenne prime in the form two to the power of p minus 1. 2 to the power of p minus 1 Mersenne prime or in the form of 2 to the power of p minus 1. This is Mersenne prime. Hence here 28 is equal to 2 to the power of 3 minus 1 into Mersenne prime. Mersenne prime is 2 to the power of p minus 1. That is equal to 2 to the power of 3 minus 1 into 2 to the power of 3 minus 1. Mersenne prime into 2 to the power of p minus 1 is also a perfect number. Can we write like that? Yes, we can write like that. Provided it should be in the form of Mersenne prime and p and 2 to the power of Mersenne prime and p should be primes. Provided p and Mersenne prime for the respective p is also a prime. Please understand the internal meanings of all these things. Once you understood what is the perfect number, then we have to see that it is actually even perfect number. We should not forget. Perfect number means even perfect number. Now, you just see 2 to the power of p minus 1 is equal to Mersenne number. What are its properties? Two to the power of p. P is an integer, is an even number. It is even number minus 1. That is equal to odd prime. Because we have discussed that for even perfect number 2 to the power of p minus 1 should be prime. That means 2 to the power of p minus 1 is equal to odd prime. It cannot be a even number and it cannot be non-prime. It is an odd prime. From the theory, number theory, what is that theory? It is Euclid's theory, Euclid's theorem. When you want to apply the Euclid theorem for even perfect numbers, they are in the form of, what is even perfect number? Please again recollect, even perfect number is in the form of 2 to the power of p minus 1 into 2 to the power of p minus 1. This should be an odd prime. And also there is a condition that 2 to the power of p minus 1, 2 to the power of p minus 1 and p should be primes. Because 2 to the power of p from the definition of even perfect number, 2 to the power of p minus 1 is an odd prime. It cannot be even number and it cannot be non-prime. It should be odd prime. Then 2 to the power of p is 2 to the power of p minus 1 is p is a prime. P minus 1 is some power. Even number multiplied by odd prime. Cannot be a perfect square. For a perfect square, for example 2 into 2, even into even. If you multiply 2 into 7, it cannot be a perfect square. 2 into 2 can be perfect square. 7 into 7 can be perfect square. 8 into 8 is a perfect square. 16 into 16 is a perfect square. 9 into 9 is a perfect square. 3 into 2 cannot be perfect square. Cannot be equal to a perfect square. Because one is odd prime and another is an even number. Hence, the squares are not perfect numbers, which implies squares are not perfect numbers. What is a perfect number? Perfect number is sum of the divisors is equal to the number itself, excluding the divisor of number itself. And it is in the form of, it should be in the form of 2 to the power of p minus 1 into 2 to the power of p minus 1, and this is odd and this is even. Even into odd prime cannot be equal to perfect square. It cannot be equal to square. Hence, it is found that square cannot be a perfect number. This is what is about the perfect numbers and Mersenne number. If there is a value addition to your knowledge because of this video, please share this video and subscribe to my channel. And I will give a very good example or very good question. I prepare myself a good question on this particular aspect of perfect numbers in the next lecture, and we will see perfect numbers, Mersenne numbers and squares. We will mix all these and let us see can we make a good, compatible and competent question, and we will solve it. Best of luck to everybody. Thank you for seeing my lecture. Please share and subscribe. This is my next lecture. Example I will be taking. Here it is only theory I have explained. A good example. My channel name is Maths and Science by IITian. Thank you for seeing my lecture. Best of luck to everybody.